and that carbon is the single most important element on the periodic table that the organic compounds that we call organic is based on. So in everything, all the organic product that you see or that you can see or touch or anything, everything has carbon in it. And why carbon? I mean, how it is producing the organic compounds? Because carbon is very important and mystical. It has 4 electrons outer side, and it can form 4 bonds, and the electronegativity is also between not that far or not very low. So it is very favorable to produce a lot of different kind of bonds to different molecules, to form different molecules. But usually carbon will bond to hydrogen, covalent bond, and then that is the hydrocarbon chain that is called the hydrocarbons. So before we move on there, our objectives for today will be the functional groups. We will be talking about the functional groups. This is different from what we have learned so far in organic chemistry. For organic chemistry, functional group is important because the property of one compound or one group of compounds actually will depend on their functional group. Functional group, what is the functional group and what do we call it? Why do we call it functional group? We'll go there later. And after the functional group we have studied, then we will try to learn how to name them, the compounds, the carbon compounds that we call organic compounds. And of course, afterwards, we will start to learn to draw the structural formula of isomers. What is isomer? Then another thing. So here was one thing. What is isomers? Another thing is functional groups. What are the functional groups? Why do we call it functional groups? And systematic nomenclature. So this is 3 different terms that I guess it is to some extent is new to us, and then we will be learning how to deal with them. Bonding in carbon compounds. So carbon, as I said, that it is in group 2, right? So no, sorry, carbon is group 14, second period. If we look at the periodic table, we will see that carbon sits in between boron and nitrogen, right? Carbon sits in between boron and nitrogen, and to its right, after nitrogen there is oxygen, and to its left there are nothing but to the extreme left there are some alkali earth metals. Okay, so if we look, let's say that this is atom, okay, carbon atom, and this is nucleus of carbon atoms. So what happens is there are 4 electrons. Okay, outer shell there are 4 electrons. So this is the inner shell. This is the inner shell. There are 2 electrons here, of course. So one, and outer shell there are 4 electrons, right? Outer shell there are 4 electrons for carbon. Do we know what is what we call inert gas or noble gas? Do we know what is the noble gas? Does anybody know what is the noble gas or inert element on the periodic table? That helium, neon, argon, xenon, all those are the inert, the noble gas. Actually, they are noble because they do not react with anyone, or they do not take participation in any type of reaction. I mean, normally under natural circumstances, they do not do any reaction. So that's why helium is so inert, and that's why we use the helium balloon, because hydrogen is lighter, but it is very much flammable. But helium is lighter too, and it is not flammable. It's very safe because it does not react with anything else, because it's very so why are they inert? Because they have octet filled up. Octet means their outer electron orbitals are filled up with the maximum electron possible. That makes them stable. This is carbon. If carbon wants to get nirvana, maybe we can say in that way, that if carbon wants to get a nirvana, that is a neon structure, right? Neon has 10 electrons altogether, 10, and then outer shell of neon got 8 electrons. 8. That means this is the nucleus. This is 2 electrons in inner shell, and the outer shell got 8 for neon. 2, 3, 4, 5, 6, 7, 8. Something like that. It is nothing like that. The atom does not look like that, but just for your, for representation, probably I can say that, illustration purpose. So this is carbon, this is neon. Carbon wants to become like neon and wants to become noble like that. So what it has to do, it has to take 4 more electrons. It has to get 4 more electrons from somewhere else. And what do they do is, each can either snatch that electron or can share the electrons. So what is better, that it shares the electron, but because if you want to snatch, you have to be more potential, more stronger. Carbon to some extent is not that strong. So it does, by sharing electron, for 4 electrons, it will share with others. And that is why it will become, a carbon is capable of producing 4 bonding. All right, carbon is capable of 4 bonding. The point that I'm talking too much, all this thing, because sometimes students make 5 bonds with carbon, 6 bonds with carbon, or 3 bonds with carbon. That is not true. 3 bonds, yeah, but there should be 1 double bond in that. But this is not true. 5 is impossible. Carbon cannot make 5 bonds. So maximum bond is 5. Either, whatever way it can make, it will make maximum of 4 bonding. So this is 1, let's say this is 1, this is 2, this is 3, which is common between 2 carbon. That is very possible, and it happens. And this is number 4. And this is 1, this is 2, this is number 3, this is number 4. And this is true for this carbon as well. This is carbon A, this is carbon B. So for A and B, both are, there are 4 bonds, and 2 of them are shared by A and between them alone, between themselves shared. That is possible. Here there are 3 bonding, 1, 2, 3, and all 3 are shared. Okay, and there is another one, 4 and 4. So the thing is, carbon can have only 4 bonds. Either it can be shared, or it can be 4 different molecules. Elements also can, like carbon, it is with chlorine, it is with hydrogen, and 2 other with oxygen. It's possible. Or 1 with oxygen and then another one with maybe something else. So this is, but the point is, it cannot make more than 4. So sometimes students ask that, okay, 3 bonds, what about 4 bonds? Is possible? Yeah, it is possible too, but the problem is it is not very favorable, and they do not also stay strongly bonded, because there are some other things that we do not want to discuss here. there will be too many electrons nearby, and then the hindrance, blah blah thing. So probably we'll know later on. So that is possible, but it is not favorable, or it does not last long. Okay, so yeah. Now bonding is done. That all 4 bonds, it is covalent. It forms the covalent bonds by sharing electrons with the other atoms. So we know there are a few types of bonding, right? One is ionic bonding, covalent bonding. So carbon cannot make ionic bonding because its electronegativity is not that higher to make bonding, covalent, ionic bonding. But covalent bonds it makes with hydrogen. It's mostly with hydrogen, so it makes the covalent bonding by sharing the electrons. So hydrogen also hydrogen also has its electron share, and then half of it, or I don't know, we can call it half or not, but carbon also get the same share of the 1 electron. How is possible, is it, right? This is carbon, let's say, and this is 4 electrons. I'm drawing a miniature of it, and here it is the nucleus, and there is let's say this is 1, this is hydrogen, and this is carbon. So this electron, there should be another one here, electron, right? So this electron is shared by hydrogen and carbon both equally. That means at the same time hydrogen has 1 electron, at the same time electron also has that same electron to it. So okay, enough. How the bonding happens, it depends on the different type of groups. Like for group 1, with the hydrogen, carbon can have 4 bonds because hydrogen makes maximum 1 bond, right? Hydrogen cannot have these 2 bonds. If anybody makes this type of thing, it is wrong already. It's total wrong. Impossible that hydrogen can have 2 bonds. Okay, so hydrogen can only make 1 bond, and carbon needs 4 bonds to make, so it can make 4 with 4 hydrogen, and that makes it a methane. It's a methane gas. Carbon can carbon can has bonding with group 17 or halogens. That is the fluorine, chlorine, bromine, iodine, all those halogens. It can form a bond because most of the halogens, they will form 1 bond with each one, only 1 bond, most of the halogens. Here, oh, okay, yeah, CX. X is equal to fluorine, chlorine, bromine, iodine. Okay, X means fluorine, chlorine, bromine, iodine, all those things. And carbon can has bonding with oxygen. It can be either single bond or double bonds together. All right, it can have single bond with carbon and double bond with carbon because oxygen needs 2 bonds. Oxygen needs to form 2 bonds because of the oxygen nature, because it needs 4 electrons. So oxygen can have 2 bonding, right? Double bond or single bond. So, and that is why carbon can make 1 bond with oxygen or 2 bonds with oxygen as well. Group 15, carbon, just the element next to carbon, that is nitrogen. Nitrogen, to be stable, nitrogen needs 3 electrons to form, to have, so it can make 3 bonding. It can be triple bonds all together or double bond and maybe another bond with someone else. Okay, another bond with someone else, and also 1 bond with carbon, and this nitrogen will make 2 other bonding with something else. But the point is, carbon can make 3 bonds with nitrogen, or 2 bonds with nitrogen, or 1 bond with nitrogen. Homologous series. Homologous series is the compound similar structure Okay, similar functional groups. Again, the functional group that we are going to learn more later on. But due to that similar structure, it has similar chemical properties. And general formula is same. So there are specific formula and general formula. We will learn it later on, but just for your our information right now, that there are two types of formula that we can specifically say that this is the formula of that compound, or we can say this is the general formula of this type of compounds. So it has those the element or compounds that are similar in their structure. All right, they are similar in their structure. They are similar, I mean, homologous series. Like those students who are in Swinburne, right, and to other institution, we say that is all the Swinburne students. Although there are many different students inside that Swinburne student, but generally we say that is the Swinburne student. So this is the homologous. They have something in common between them because they will go to the same university, same library. Anyway, so this is the homologous series. And for each member of the homologous series differs by CH2 group. This is the methylene group. Okay, so the members of the homologous series can be very much different from one to another one, but their chain differs by one CH2 group for a homologous series. That means it can be CH2, CH3, CH3, 1. It can be one CH3, CH2, CH3. This is the another one. It can be CH3, CH2, CH2. Let's say another CH2, and then CH3. All right. So all of them, this is number 1, this is number 2, this is number 3. You see, all of them are different, but generally very similar to each other. Only the difference between them is one CH2 group, right? This group is different from here to here. And from here to here, we see there are 2 more, or maybe 3 more, or 4 more different. Now, there is another way we can express this number 3, or likewise, if number 4, that means CH2, 1, 2, 3. We can have 4 or 5 or many, right? So what we do is, it is cumbersome to write all those CH2, CH2, CH2. What we do is CH3, and then in the bracket we leave all the CH2 and then denote by how many times they have occurred in the chain. For this number 3, there are 3 times, right? So we just write number 3 and CH3. The CH3 should be there. So yeah, this is the much easier, faster, and less tiresome way to write it. So this number of 3, it tells us how many times the CH2 comes or occurred in the chain. This 3 can be many. It can be 20, it can be 25, many times it can have. So yeah, that is just to show, I mean, tell you that this is how we write the homologous series, but all of them are in a same homologous series and they differ by one or many CH2. Yeah, methylene group. This CH2 is a methylene group, it says. Now we are coming to functional group. So we have seen this type of compounds or structure of the compounds previously, and we are, to some extent, probably we are familiar to this. We are also familiar to this type of chain of organic compounds, and then there are OH. Let me change the in color again. Should I take a green color probably? Yeah. So we have we know that CH2, CH2OH, or maybe COOH. This is, we know that from the acetic acid or ethanoic acid, or maybe NO2, or maybe, you know, sometimes it may be just Cl, a chlorine or bromine or iodine, something added to that, right? So this is what we know is these groups that are attached are called the functional group, and the name implies their attributes. They are functional group. They do the functions. So it's an atom or a group of atoms that gives the characteristic set of chemical properties. So they do the function. The chemical property changes, right? The chemical property changes or chemical reaction occurs for that type of molecule is due to that functional group, right? And it is easy to understand or to identify one organic compound based on their functional group, right? To know whether the functional group is working, or I mean, what type of functional group is there, so that we know that what type of reaction can occur there, or how it may behave in some unknown circumstances, how it may behave. Due to the functional group, we will be able to know that one. All right, so this is, and this is easy. I think this is easy, right? This NO2, COH, OH, Cl, or bromine, that is Br, chlorine, Cl is chlorine, iodine is I, and all those things. So these are the functional groups. Nitro, NO2, COOH is carboxylic group. So these are things actually the functional group. Problem is to name them, right? And sometimes it is hard for us to name it, to remember the names. So, but it is important. We understand that we cannot recognize or remember all the names of the functional groups, but many, I mean, few of them we can still, I mean, we should remember few of them. Some of them are chloro, that is when the chlorine group is attached, that is called chloro. When hydroxy group, that is alcohol, that is hydroxy OH. Carboxy COOH group. Amino group is, oh, this is a bit, nitrogen groups are some. We need extra attention because the name changes. This is amino group, NH2, and then there will be amide group, similar thing, and then nitro group. So these are the things that we, some of them, at least few of them, we should remember the name. It doesn't matter that, I mean, it is not absolutely necessary to remember the names, as long as you can differentiate from one to another one and you find out what the reaction may occur. But few days ago, our student from the final year project, they are doing the final year project, and they had to go do some experiment with this amide group. And you know, that time it is very easy to express that what type of compounds are here, and I want to do what type of reaction. I'm looking for what type of problem, I mean a solution here, so that it is easy for us and to remember and find out and to know the property, what could happen because of the group. Okay. Okay, so this is a functional group, and R, these are representing the main backbone of the organic compound. Alkyl group. This is alkyl group. That means CH. There are carbon group, and there are carbon and hydrogen are attached there. Just now, what we have seen it. That this is the rest. Except from that functional group, the rest is represented by the R group. So CH3, CH2, 222, whatever is there, that is all are represented, coded by R only. And when we are saying R here and R prime, right? So these two are different because that means that this R and that R are different. They are not same. Okay, now alkyl group. There are different type of alkyl group. That can be an alkane, that can be an alkene, and that can be alkyne. So alkane, why we call it different names? It will be easier to remember that the carbon between them, because the carbon is the backbone, right? We have seen it before, that CH3, just now I wrote CH3, CH2. I wrote in that way, isn't it? So I can also write a bit elaborative way, that is CH3 means there are 3 hydrogen all around it. Just hold on, I need to take my specs. So here I just wrote in that way, right? That CH3 and then CH2, CH3. So CH3 I can write in this way as well. The hydrogen is all around it, and then the 2 hydrogen, is on the either side of carbon. So in that way we can also write. So when there is only one bond between carbon and carbon, there is only one bond between carbon and carbon, that is called alkane. That is called unsaturated. All right. So it can be another carbon attached to this carbon as well. And then this carbon is attached, and then there are 2 hydrogen. So if we count on, we will see that all hydrogen, all of them has 4 bonding. All of them has 4 bonding. This carbon, consider that this is number 1, number 2, number 3, number 4. And this carbon as well has all 4, 1, 2, 3, and 4. So all of them are having 4 bonds all around it, and none of them, carbon, is actually double bonded. There are no double bond between carbon to carbon. So that is called saturated. That means there is no other space for any other bond to go in, or anything to, there is no other space to squeeze between them. It is saturated already. So that is called alkanes. Alkanes means they are saturated. They do not react further with hydrogen, and only contain that single carbon-carbon bonds in the molecule. Okay, so all those things, that methane, ethane, propane, butane, pentane, all of them are having enough hydrogen in their molecule. in the molecules, enough hydrogen in them. So there is no other space for hydrogen to go in or any other things to go in, because there is no other space. What do I mean by no other space? We will see it. Just remember that when there is a saturated means there is no double bond, so that nothing can go in. Unsaturated means something can go in and there is a double bonds between them. So alkanes, this is the hexane. This alkane also can be a cyclic, that means a ring. They form the ring. That means you know that head and tail is together. If this is the head, this is the head, all around it goes out to the tail, and the tail is connected to the head. So I mean, anyway, you want to remember, you can remember, but this is a cyclic chain. Okay. Yeah. So this can be a cyclic or a straight chain. Both way possible, as long as there is no double bond between them and all the carbon is attached to the maximum number of hydrogen it can be attached to form 4 bonds, that is a saturated hydrocarbon. And for this type of rings, right, I mean, in next lecture or after next lecture, we will not be looking more into this type of skeletal structure. Okay, we'll be looking more into this type of structures, and when we look at this, there will be no carbon shown here. But when we look at when we will look at it, we will know that this means a carbon is there. At this corner, there is a carbon atom. There is a carbon here, there is a carbon here, there is a carbon here. And all those carbons are having 4 bonds attached to it. So this carbon, I'm talking about this carbon, you see, this is 1 bond, this is number 2, this is number 3, that is bonded to 1 hydrogen, and number 4 to another hydrogen. Same goes for here, this carbon I'm talking. So this 1 bond, this is another bond. There's number 1 and 2 bonds are connected or bonded to another 2 carbon. And then this is number 3, that is bonded to hydrogen, another hydrogen is 4. So this way, 1, 2, 3, 4, they, I mean, all carbon are bonded by 4 bonds. Systematic name. Now, here, as we have seen, that this is called hexane, right? This is called hexane. Why do you call it hexane? This is 2-methyl-butane. This is a little different. It's cyclobutane. The name cyclohexane, cyclobutane, the name suggests that they are cyclic, right? They are cyclic means their one end is attached to the another end. All right. So if there is a 2-methyl-butane or hexane, how do we know that, or how should we, if there is something like a strange chain, looking at it, how do I name it? There is a system to name them, and this is called systematic name of the organic compounds, and that consists of prefixes or prefix, root, and suffixes. So before we go to the prefix and suffix, the root is the backbone, the maximum or longest chain of carbon and hydrogen, right? The longest chain the carbon and hydrogen has, the maximum, the chain, or that is the what do you call it? The main branch. We call it main branch. The longest continuous chain. So longest continuous chain is the carbon that consists of carbon is the root. What about the prefixes that we put in the first place? Prefixes are the substituted groups. All right, substituted groups. Just now we have seen the functional group, right? So functional groups are, okay, the functional groups are the suffix that is coming at the end of the name. The main functional group, whatever the nitro group or chloro or acetate, or whatever, the functional main group is coming at the end of the name, and then the prefixes that is coming at the beginning. Prefix means something has been replaced with one hydrogen on the main root of the structure, like one bromine, or one chlorine, or one any other things that has been nitro, or any other things that has been substituted by this one hydrogen in the main root. That will be the prefix, and the main functional group will be the suffixes. It will be easy, more clearer when we go or we look at some of the examples. So the root name, when we use the root name, we have seen that the name is methane, ethane, propane, butane, pen. But here, this is just and right? H4 means there are 4 hydrogen around carbon, and that is called methane. 4 hydrogen around carbon, that is called methane. If it is ethane, then there is another CH3 is attached to this carbon, right? If it is like propane, so another carbon and 3 hydrogen is attached to it, and this goes on. So this is just the backbone, that is the root. And when this root is in a complex compound, this is a complex compound. When there is a root is just part of the whole structure, there are prefixes and suffixes. So the name, that is methane, ethane, propane, does not stay as it is. It gets distorted. How does it get distorted? It is like meth, eth, prop, but, pent, hex, in that way, accordingly. So from methane it will be meth, from ethane it will be eth, from propane it will be prop. In that way, the name changes, or name will be called in that way. Suffixes name. All right. So the functional group, of course, suffixes are the functional group, and there are so many functional groups we cannot possibly remember all of them, and some of them that we can remember and we should remember is better that we remember, so it will be easier for us to instantly understand or know the things later on. So amide, when carbon, the nitrogen and compound, nitrogen is that as CON, amide. Ester, that is COO, and then later there is a C. This O is related to C. Ester and carboxylic, is the difference between them is this oxygen is attached to one carbon, this oxygen is attached to one hydrogen. So this is the difference, right? So this is the ester and one is carboxylic acid. And then is ketone. Ketone is this CO is attached to in between 2 carbons, carbon and carbon. So in that way we can we have the different type of groups, functional groups. And the prefixes, these prefixes are methyl, ethyl, propyl. So this thing, when it is not in the root, when it is in the root, we call meth, eth, prop, right? But this thing, when it is using as a prefixes, that is substituted on the root, like methane, the root is, let's say, the propane. This is the longest chain, so it should be the root, and methane is attached to somewhere here. So what we will call it, methyl, which will not methane and propane. We will not call that. We will call methyl propane something, methyl prop something. Okay, so that will be the way we will call it. And the systematic naming protocols that goes in this way that there is a compound, we have to identify the longest chain, right? The longest chain. We have to start counting from the longest chain, and then we have to find out who is the main functional group. We start counting from that side, the main functional group side. Okay, if there is no functional group attached to it, then we will start from the prefixes or the substituted from that side. So for this is the root or backbone, that CH3, then CH, then CH2, then CH2, then CH2, then CH3. So all these things are in the backbone, and then there is no functional group here, but only the CH2 is replaced by one hydrogen here. It was supposed to be two hydrogen, right? It was supposed to be two hydrogen, just like this. But one of them, the hydrogen, has been replaced with the CH3, or CH3 has been replaced with that hydrogen. Okay. So that is the prefixes. So this is not a functional group, but this is substituted onto this main backbone. So that is a prefix. So now we'll start counting from where there is a substitution occur. So this is the fastest way I get closer to that substitution, or this is I will start counting from this end, because this end, if we start counting, the substitution is coming earlier. If I start from this side, I will have to 1, 2, 3, 4, 5, and then it is 6. So the substitution is coming at 5. But if I start from this side, so it is 1, 2. So it is coming earlier. So this is the way that I will start counting from where the substitution can be approached earlier. And then number the carbons, of course. We see that the substitution occurred at second carbon, right? So this is methane, ethane, propane, butane, pentane, and hexane. So 2-methyl or methyl. As I said, I mean, we saw before that if methane is substituted, so the name will not be methane anymore, it will be methyl. If ethane is substituted, the name will be ethyl, and so on. So here, this CH3 is coming from CH4, right? The CH4, one hydrogen is gone from CH4. There are 4 hydrogen all around it, right? 4 hydrogen was all around it. And then these 4 hydrogen, one of them goes away. One of them goes away. If it goes away, then it creates an opportunity for this methane to form a bonding. Otherwise, it is already packed. It cannot have any other bonding. It cannot have any other bonding because it is packed and it is saturated. There is no other way that it can form another bonding. So if only the hydrogen goes away, then only it has a chance, because there is an arm coming out from that hydrogen left. So the arm becomes empty. So the carbon can hold other one with that empty arm. Otherwise, it cannot. And that is why it has to be CH3. If somebody writes CH4 here, that is wrong, because carbon cannot have more than 4 bonds. If you put 4, that means you are giving carbon 5 bonds. That is very, very wrong. So this is 3, carbon can has only 3 bonds. Here methyl means CH3. So the CH3 is bonded with CH. So both carbon, this carbon and this carbon, both of them are having 4 bonds. You can count on, there are 3 here and then 1 here, that is 4. And there is 1 here, hydrogen, there is another bonded here, another bonding here, and another bonding here. So altogether it is 4 bond to this for this carbon. So all carbon are having 4 bonds. Now the name for this is 2-methyl-hexane. Now we are going for a little bit more complicated, but anyway, the name is given here. But let's see how do we find what will be the name. So first of all, we have to find out which one is the longest chain. Why it was supposed to be animation anyway. Okay, so we see that if we start counting from here, that 1, 2, 3, 4, 5. But there are carbons here and there, so we cannot stop here. We should not count 5 till there. We will go 5, 6, and 7, or this is 7, or this is 7. So all to either side it is 7. So you can just take any of them. If we start from here, 1, 2, 3, 4, 5, 6, 7. So the same thing. If we start from here, is 7 carbon, the longest chain. If we start from here, it is 7 carbon as well, the longest chain. Now the interesting thing is, from which side should we start counting? Right? Should we start counting from this side or from this side? And why? Does it make any difference? Does it make any difference? Yes, it does, because we have to see where the chain becomes, the fraction comes earliest. And not only earliest, but also the maximum, the bigger fraction or bigger, what do you call it, bigger functional group or prefixes attached. So for here, if we start from this side, this CH2CH3, or actually if I start from here, the same thing. Let's say I start from here, same thing. So the CH2CH3, this is ethyl group, right? This is ethyl group. It is attached to this number 3. Same thing happens if I start from counting from here. We just need to imagine that way, that if it was the straight chain, this CH2 is being attached to this carbon 3, right? The same thing. So this ethyl group is attached. So this ethyl group is bigger than CH3, that's a methyl group. So we start counting from this side. Now we have found out the longest chain, that is 7 carbon here, and then is that 7 carbon here. 7, the longest chain is 7 carbon, and then okay, so since 7, so what will be the name? 7 atoms of carbon atom. So methyl, ethyl, propyl, butane, pentane, hexane, heptane. So it is hept, right? And heptane, from heptane, we cannot use the heptane, we have to use hept here. So this is prefixes name. Where is the root name? We have to use the root name because this is the longest chain. So 7 carbon, 1 carbon is methane, 2 carbon is ethane, 3 is propane, 7 carbon is heft. The root name it will take is heft. So this is heft, right? And then there is no double bond in between the carbon and carbon. So this is this is saturated, not unsaturated, and that is why it will be alkane, not ANE. This is ANE, alkane. There is other things, alkene and alkyne, we'll see later on. Since there is no double bond, which is alkane. And the substitutes now. right? Substitutes now. There is no functional group, we can see. There is no hydroxyl, carboxyl, or any other things. But the substitutes, there are many substitutes on this backbone. And let's see what are the substitute. At number 3, carbon number 3, there is the ethyl group, right? There's the ethyl group. And at number 4, it was supposed to be at number 4. Okay, let's say this is attached to this carbon. So this is a methyl group. And at number 6, this is number 6 carbon, and there are 2 groups attached to it. One is methyl, another is methyl as well. So there are 3 methyl group all together substituted on this backbone. So there are 4 at one is at 4 position, another 2 is at 6 position. So 4, 6, 6 trimethyl, right? One at number 3 is ethyl group, and at 4, 6, 6 trimethyl, and then of course it is a heptane because het. And this is an alkane, so A and E will be added. So this is how we will be calling them, or this is the way that IUPAC name. There is a organization, International Union for Physical and Analytical Chemistry, probably I forgot the exact name. So they are the one that produces the ruling, and that is how all the chemists in the world they can recognize the name, the product, the compound's name, or they call them that way. Okay, so now alkane is gone, alkene is coming, and it is the same thing, similar thing actually. Only the thing is there will be a difference between carbon and carbon, and then, oh, I missed it previously. The general formula for alkane will be, there will be another +2 here. That means the formula will be the number, the many carbon is there. There will be the double hydrogen +2 hydrogen will be in that molecule. But for alkene, there will be exact double number of hydrogen as of carbon in the molecule, because there is a double carbon-carbon double bond between them. And the alkene homologous series general formula is here, and the name is there will be no methane. There is no methane because there is only one carbon in methane structure, methane compound molecule. So there is no chance to make a carbon-carbon double bond for methane because it makes only one carbon. But for ethane, it is possible. So this ethane can have double bond, and in that case, each carbon will have 2 hydrogen on it. So that is called ethene. This is not the bonding, yeah. So it's called ethene, and same goes for propene. And if there is double bond between propane, right? So here, here, and here. So this is a propene, methane, ethane, propene. Sorry, methane, sorry, ethene and propene. So E and E at the end of the name, it will be added if there is a double bond, one double bond between them. All right, and it replaces with E and E. And the nomenclature also says the same thing. Like we have to find out the longest chain, and it should start from where the maximum number of, sorry, the unsaturation starts. So we should start counting where the unsaturation. There are quite many rules actually, but we need to remember many of those. It is good to start from the very beginning. That previously I said that where there is more unsaturation or bigger number of substitute, we start counting from that end. But when there is a unsaturation, we start from that end. Again, depends on if there is a hydroxyl group, carboxylic group, we start from that end. So there are quite many different type of ruling, not different type, there are quite many number of rules and regulation that we should be following when we are doing the nomenclature. So still the same thing, we start from the counting longest chain, and then we find what are the substitute, so that the prefixes, and then the functional group we will be finding all those things. So for this, we see there are 4 atoms in the main carbon chain, main carbon backbone. There are 4 carbon length in the main backbone root, and at number 4, there are 2 fluorine is actually replaced or substituted on this 4th number of carbons. So, and there is one methane group, methyl group actually at 3 number carbon. So we start from that way, that 4,4-difluoro 3-methyl-but1-ene. So there are at number 4, there are 2 fluorine and 2 fluorine, right? So we cannot say that 2 fluorine, because it is not fluorine, it's a fluoride ions, right? It's fluoride ion. Only if it is like that, only then it will go and make the bonding. So so this is not fluorine, but fluoro. So 2,4 difluoro 3-methyl-butane. Some of you can ask that why didn't I start 3-methyl-but 4,4-difluoro-1-ene, but1-ene? Why did we start? Well, we have to follow another regulation that the substitute's name, that according to the English alphabet A, B, C, D, whichever occurs faster or earlier, according to that English alphabet, we have to use that before. So F occurs before M in the alphabet, right? English alphabet. So that is why 4,4-difluoro, it came here. If there was a chlorine or chloro group at 5, so this 5, or anywhere else, then chlorine would come earlier because C is before F. So that is how. And then at the end, but1-ene, that means it tells us that there is a double bond. It's in E, that means there is unsaturation. And 1-ene means there is one double bond, a double bond at one position. This is butane molecule. We understand this butane molecule, there are 4 carbon length of molecule is there. And in that molecule, there is one double bond. And where is the position of the double bond? This is number 1 position, double bond. Let's say there was another double bond here. Let's say, just for the sake of our understanding or discussion, there was another double bond. And the chain continues for some time. So what would say that 1 and 4-ene. 1, 4 -ene. So if somebody showed this molecule, the name of the molecule, no need to draw this big structure, just show the name written, and then I would know that, okay, there is a what is that, unsaturation, that is the alkene, That means there are two double bonds in the molecule, in the compound, and there are two double bonds at 1 position and at 4 position. So this one actually is telling me that there is the double bond at 1 position. Okay. Structural formula. There is another category, that alkyne. So we have seen the alkane and alkene, right? Alkane, that is no double bond between carbon and carbon. Alkene, there is at least one double bond between carbon to carbon. There is another category that called alkyne. When there is carbon-carbon, there is a triple bond between carbon and carbon. But it is not discussed here. We probably didn't discuss here also. Or did we? No, we didn't discuss. Okay, I forgot actually. All right, so the structural formula. Structural formula is, this is the full structural formula of butane. It's methane, ethane, propane, and butane. That means 4 carbon atoms in there, in that molecule. And of course, there is no double bond between carbon to carbon. So all are filled up with hydrogen atoms, right? This is semi structural formula for that butane. All of them. Anyway, you write, all of them are semi. Most of the time, we write in this form. We just group up all those common groups in between them. We group them up together for our simplicity of writing, and also it looks good, saves time, you know. So this is a molecular formula, C4H10. What is the need for full structural semi-structural? C4H10, it can be of many things. It can be of many things, all right? There can be a different things there. What are the different things or different compounds? C4, that means there are many compounds that can have 4 carbon and 10 hydrogen in different ways arranged around it. And just one hydrogen from here to there would make the whole thing different. Although their molecular formula will be same, but their property and their category will all be totally different, right? Their physical and chemical property will be changed. So how? Let's see. That is called isomers, right? Those are isomers, that their same number of atoms, similar atoms together, but their orientation or arrangements are different. Just now we said the butane, right? C4H10, and this is the skeletal structure, C4H10, that is this way, and this can be rearranged to this way as well in number B, right? So this is totally different, 2-methyl propane, which has a different property, different reactivity, different functionality than butane, right? Just because this carbon, I've severed it from here, and then I bought and attach it there. So that makes it 2-methyl propane, which is very much different from one another. So structure isomer, C4H8, that is H8 means we understand that there will be a double bond between them, otherwise there will be 10 hydrogen. Since there is no 10 hydrogen, there is 8 hydrogen, that means the extra 2 bonds should be attached to each other. So it can be but1-ene, can be a chain isomer, right? that means which is attached by chain to methyl propane. Positional isomer, that means it is still the same thing, only the position of the double bond change. So from, let's say, it's number 1, number 2, number 3, number 4. So the double bond shifts from number 1 to number 2 here. And then this is also different. It will have different property. Not totally different, but to some extent it will be different. And this is a positional isomer. Functional group isomer, which is, it is the linear, right? This is linear, and here there is a double bond between carbon-carbon, but for when we make it cyclic, there is no, this is not linear. This is not linear, this is a cyclic, and it's totally different. It will have a different property, different physical chemical property, and everything. All right. So this cyclic structure usually can be represented in this way. So whenever you draw a what do you call it? 4-arm. What is that? Oh. Tetragonal, is it? Forgot. Okay, so whenever you draw a triangle, or what is it called? Anyway, so this is simply, it can be represented in this rectangular, yeah, it's a rectangular structure. It can be just a rectangle. If we draw, that means it is a cyclobutane. If we draw a 5 pentagon, that means it's a cyclopentane. When we draw a 6-arm structure, which is cyclic, is called cyclohexane, and so on. So, structural isomer of C6H12. So there is C6H12, and we understand that this is one hexene because this is just falls in the structure or formula of CnH2n, that is alkene. So this is the same, just the double number of carbon or hydrogen will be there. So there is a double bond between them. So it is here one double bond between them. Or chain isomer, we can just one remove and attach to somewhere else. It will produce a chain isomer in that way. Or we can have the positional isomers. There can be many positional isomers for it, and also a cyclohexane like this. So when there is no double bond between them, of course, there is no other double bond between them, because the head and tail is stuck together or attached together, and then there are between them there is they will produce a box like that. Examples of functional group isomers. So this is hydroxyl, a functional group, but this, when we write or there is a different type of molecules, if we do not show the functional group properly, just if we just write that how many carbons are here, 1, 2, 3, right? So there are 3 carbons. And how many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8. So H8O. H8 and O. So this is, it's written here. So this is propane-to-all, which is very much totally different than methoxyethane, which is a ketone. which is a ketone, and this is an alcohol. We will see later on, but this is an alcoholic group, this is a ketonic group. So this is totally different. They have their different chemical and physical property. They occur differently. Their reactivity is different, totally different. So this is two different things. And that is why we need to, not only the formula, we need to also have the structure formula for these to understand better, for better understanding of them. The same goes for carboxylic acid and ester. If we do not, by this structure, we cannot find what is the structure of this and what will be the reactivity for this. Other functional groups. There are chlorofunctional group, amino functional group, hydroxy functional group, carboxy functional group, ester functional group, OCO, but make sure that there is carbon on both, otherwise there can be different. Okay, so chloroalkane. General formula is RCl. R means, of course, we have seen it before, right? R is the backbone, the CH hydrocarbon, R is the hydrocarbon, and Cl is the chloro group. And this chloro group starts with the chloro and then alkane, from which is derived. So chloroalkane, or 2-chloro-3-methyl butane. For this, we see that methane, ethane, propane, butane. So the longest chain we were counting 1, 2, 3, and 4. So longest chain we counted, there are 4 carbon in that long chain, and at 2 position a methyl group is replaced or substituted. The functional group is chlorine. So the prefix comes first, right? Chlorine will come first, but chlorine we cannot write because chlorine and chloro is different. Chlorine means individual or independent molecule, but chloro, that means it is attached. So this, oh yeah, I made the mistake. You see, we should start counting from this side because chlorine is 3 and 4. Because chlorine is the, what do you call it, bigger and is more electronegative in that way. So we start counting from this side where chlorine comes earlier. So chlorine, chlorine comes earlier, and then C comes before M. So we should write 2-chloro-3-methyl butane. This methyl CH3 groups is arriving at 3 position, and this is how we should be writing. So 2, and between 2 and chloro there is a dash. So 2 and dash CHLORO, right? Chloro, in that way, and then between them there is a dash 3 dash methyl. But if there were another methyl, methyl group in another position, I could just put a 1 comma and write 3,5 or 3,7 and then dash something. So when there is similar thing, we can just put comma between them and write. Otherwise, we should put 1 dash between the numbers that we are writing. And same goes for this thing, that methane, ethane, propane, butane. So there is 4 carbon as well, and there is a butane, and this chlorine. From the other side, we start counting 1, 2, 3, 4, or 1, 2, 3, 4. Both sides it will be the same position, 2 and 3. So it doesn't matter. We can start counting from the other side. So 2,3-dichloro. There are 2 chloros, so dichlorobutane it should be. So dry, tri, tetra, penta. In that way, Latin we should be used, not 2-chloro. Okay, 2,3,2-chloro. If you write, then it would be wrong. You will not get the marks. Same thing goes here. that we start how many? 1, 2, 3, 4, 5, 6, 7, 8. This octa, and then this is the chlorine is error. I mean, we can approach to chlorine from the this side earlier. So this 3. So 3 chlorooctane. It should be. Oh, there is another chlorine here. Oh, there are 2 chlorines, right? This one, this another one. So 3 dichloro. 3 dichloro. It should be named CHLORO. Chlorooctane. In that way, we should be right. All right, product constant contains chloroalkane. The chloro and alkane, that means chlorine is attached there, and also they are alkanes. So those few of them are DDT. This is the DDT. If I had time, I could talk a bit about it. This is the DDT. Those now are maybe 50, 60-year-old. They would know that this DDT is one of the best pesticide that we used and terminated that malaria in many countries because of this. But the problem is this is so strong, it killed many bird and many other species also become extinct because of this DDT. So from 1970, I think, I'm not sure exactly when, but from 1970, 75, 77, worldwide, there was a consensus that we shouldn't use DDT anymore. So DDT has been stopped producing. But some countries, of course, there are bad people always. They secretly and illegally produce it. And this is very bad for human health, in fact. And that DDT, this is the structure of DDT. So DDT means diphenyl dichloroethane. Okay, DDT. Not dichloro. Diphenyl. This is one here. This one here, carbon. Oh, I forgot the name actually. Diphenyl. Oh yeah, you remember? Yes. The dichloro. There are 2 chloro here on the phenyl group. This is the phenyl group. So this is dichloro, diphenyl, trichloro. This is 3 chlorine. So this is trichloro, and then this is the ethane, right? 2 carbon and carbon group here. So methane, ethane. So trichloroethane. So that is the name for this compound, and the structure is this. Freon as well. The freon it's not used anymore for the refrigerant coolant gas. It is also a very bad greenhouse gas and not used probably anymore. Okay, so now we go for the functional groups. Amines, NH2, right? There are NH2. When we know ammonia, NH3. Right, we know ammonia. So this amine is coming from this ammonia. So when is ammonia, it is to some extent stable, right? It's stable, and it is an ammonia gas, and is of course it's a dangerous gas for us, but it is also very important for us because a lot of more fertilizer are being produced using this ammonia. So I'm just telling you all those things so that probably it will be helpful for you to remember. So this ammonia, when there is one hydrogen is gone from here, there will be an arm coming out or empty. That arm is here. So this amine is coming from ammonia, right? This amine is coming from ammonia. So this amine group is here, and then when it is attached to this hydrocarbon or CH3, CH2, CH2, CH2 in this way, so we call it amines or amino group. So for this case, we should start counting from this side, because from this side, if we start counting, the amino group comes earlier. So 1, 2, it comes at 2 position, 3, 4, and then 5. If I start counting from this side, 1, 2, 3, 4, it comes at 4th position, which is not very far from 2. So why shouldn't we count from that side, right? And then 1, 2, 3, 4. So the amino group, which is coming at number 2, and that is why it's called 2-amino, and the methyl group or methyl group is coming at 3 positions. So this is 3-methyl pentane. And since amino starts with A, of course we are writing, it's not because the 2 position, because of the name which is occurring on the earlier in the English alphabets. So A at the first alphabet, so of course it will start from that side. And this is a very polar. NH2 is a very polar, which makes amines more reactive than parent alkane. Alkanes, by the way, are not polar, all right? So CH2, 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 like that. This is the root of them, whatever it is, methane, ethane, propane, butane, pentane, hexane, whatever, they are not polar, they are not very active, or they are very unreactive. But when there is a hydroxyl group or amino group or COOH or chlorine, right, or chlorine or bromine, anything is attached to them, that makes them more active. For amino, NH2 it should be. So for amino group, it is a polar group. That means because it has lone pair electrons, which we'll learn later, it has lone pair electrons and it can attract more electron towards it or give. So it makes the nitrogen is electronegative, so it can attract more electron, and that is how it becomes polar. And when it becomes polar, it is already susceptible to either for electron attack or for electron donation, and either way the reaction occurs, right? So that is why when there is a polar group attached to this backbone, it makes them chemically more reactive. The systematic name for this should be we should start from this side, 1, 2, 3, 4. So 2-amino butane, 2-amino butane or butanamine, 2-butanamine as well we can call, but 2-amino butane is much better to say. Hydroxy or alcoholic group, right? General formula OR, ROH. R, of course, means the parent chain for that. Parent chain, CH2, 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 and the functional group is hydroxyl group is the functional group as well. This is polar bond and able to form hydrogen bonding. What is the hydrogen bonding? Anyone has idea? Are you guys there? What is the hydrogen bonding? And do you know what is the hydrogen bonding? Anyone has an idea what is hydrogen bonding? Today we cannot finish because that's why I don't have any main question. Next week we will have. But what is the hydrogen bonding? Anybody has an idea? Just no idea. Vanessa, you are so quiet today. You there? No. Okay. So hydrogen bonding is kind of weak bond that forms between a polar positive and negative ions, atoms. So when hydrogen is for water molecule, right? Water produces a hydrogen bonding. We will write it. So let's say water is like this. This is oxygen, and the hydrogens are there, right? So oxygen already have two lone pairs. That means 4 electrons, 2 lone pair electrons. So what happens is, since oxygen has more electrons on each, and electron always carry negative charge, right? You have seen it before. Electrons are negatively charged and protons are positively charged. So this is 4 electrons. Of course, there will be a negatively charged, a little bit more negative. Oxygen will be a little bit more negative. That it is not neutral, a little bit more negatively charged. And hydrogen, it is due to this negative charge, it becomes a bit positive charge. It also feels the heat because oxygen is negatively charged. So hydrogen has to balance that one, forms a bit positive charge. Same thing goes on here as well. Let's say there is nearby another oxygen molecule, water molecule. So the same thing, it has these 2 electrons and 2 lone pairs. So this is negative charge. So what happens is this hydrogen and oxygen, they form or they find a bit attraction between them because they're positive and negative charge, right? Same thing goes for this hydrogen, this oxygen to other hydrogen, this hydrogen to other oxygen. So these are the hydrogen bonding. And because of this hydrogen bonding, water has a higher, what do you call it, boiling point than it appears, right? Water was supposed to be boiled at 35 degrees centigrade or less than that, maybe 20 degrees centigrade. Water is supposed to be vapor, but it goes up to 100 degrees centigrade because of this property of water. Okay, and this hydroxyl group, since this hydroxyl group, the same thing, the oxygen will have the lone pair electron on it, and it will become negatively charged. Hydrogen will be positively charged, and it will form a hydrogen bonding to nearby molecule who has the hydroxyl ion as well, right? So the methanol, ethanol, they have also these hydroxyl ions. This hydrogen bonding between them. Classification of alcohol. There are 3 different types of alcohol. One is primary, secondary, and tertiary, right? Primary alcohol, what do we call it? Primary alcohol. Primary alcohol is, there is the hydroxyl is attached to the carbon where that carbon has 2 hydrogen. Okay? That carbon is attached to another 2 hydrogen. Of course, that carbon should be attached to another carbon. That is not the question. But the thing is, this carbon must have another 2 hydrogen around it, so that it is the primary. Secondary is the hydroxyl. This hydroxyl group is attached to a carbon. That carbon is only attached to 1 hydrogen, and then that carbon is attached to 2 other carbons. Right? Either way, either this carbon, carbon is attached to 2 other carbons, or that carbon is attached to one hydrogen. That will be the secondary alcohol. Tertiary is the carbon that is attached to the hydroxyl group. It is not attached to any hydrogen, only to other things, but no hydrogen. All right, so that is called tertiary. So primary calls that maximum number of hydrogen, that is 2 hydrogen is attached to the carbon. The same carbon is attached to the hydroxyl group. That is the primary. Secondary is the hydrogen is attached to the carbon, where the hydroxyl is attached to the carbon, that's only one hydrogen is there. So that is the secondary alcohol. So it will take some time, but if we try, if we write it on the paper and try, it will be easier for us to remember. Compounds contain hydroxy ion, right? All those things, too many things. That ascorbic acid is the vitamin C that probably we take. I just took this morning. How? Through the languages. I took the Iceland tea. So I think I had the ascorbic acid, the vitamin C I had. And then anti-freeze in the cold countries where the temperature is below 0. So what do they do is, their car, to the radiator will be burst if the air or water become in the radiator, right? There is water, and the water it becomes freeze and ice. The radiator will burst out. So to protect it from freezing, percentage of this glycol, it's called ethylene glycol, is used to use it for antifreeze. But the problem is this is also environmental concern. It is not good for our environment. This causes a lot of damage to our environment. So now the chemical engineering things are going on to produce. Of course, there are some alternative bit, but we also have found some other propyl glycol, or the search is ongoing to find a better way on one. And then the production of propyl glycol, how should we produce, at what temperature, and how long should we keep it, what will be the diameter of the reactor, and the reactor, how much the temperature will it go up, all those things, the calculation, a lot of calculations going on to produce that. Those who are coming to chemical engineering, if you take the project, you will learn more about it. Carboxylic acid. So the general formula is COOH. When this COOH group is attached to the backbone, COOH group is attached to the backbone, right? So it is called carboxylic. And carboxylic group, since OOH group is there, it is also polar. It also causes polar because this is how it can dissociate. And I think we have seen it before, right? Acid and base, that ethanoic acid or acetic acid, we have seen it before, and that is how do the dissociate. So this is so when there is a carboxylic acid in the water, so it will produce make the water more polar or more ionized in that way, right? And the reaction can occur far more better way than if there is no any carboxylic group. The name will be replaced by OIC, oic. So methanoic, propanoic, butanoic, OIC, oic. For this case, this is methane, ethane, propane, right? Then it is butane. So this carbon is always considered in this way. So methane, ethane, propane, butane. So it's the butane, and then this is 3-methyl. This methyl group is replaced here at 3 position. Again, we'll start counting from this side where this the substitute, the functional group comes at the beginning, at the first. So if I start counting from the carbon, 1 is there. I consider this the number 1. So that the carboxylic group occurs at number 1 position. So 3-methyl or methyl butanoic acid, or 3-methyl butane 1-oic, also possible. 1-oic, OIC. Butane 1-oic acid is also possible. So we know that at 1 position there is a butane carboxylic group is attached. The isomers, again, the longer the chain becomes, this is 4 carbon chain. If it's 5, 6, or 7 carbon, the more possibility of finding the isomer grows. All right. So this is a carboxylic group. It is here, but for this case, it's an ester. So for almost similar, only this oxygen, it goes between here, between carbon and carbon. Okay, this carbon and this oxygen goes between carbon and carbon, and the total things is different. Total property is different for this case. Ester is one of the things that has characteristics, smell, the flavor it has, and we are going to see it for the week 8, lab 8. For the ester, we'll see a lot of flavors. We'll produce a lot of flavors for it. So this is the ester is the functional group. Actually, there should be R and R, 2 hydrocarbon should be attached on the either side. Then only it becomes the ester. So functional group is ester and OH. The name comes the OH at the end of it. And for ester, there will be 1 carboxylic group, 1 alcoholic group. Okay, alcoholic group and carboxylic group together, it bonds together, becomes an ester. So since carboxylic group and alcoholic group come together, the name, alcoholic group name, should come first when we are naming them. So whatever it is, methyl group or ethanol or methanol or propanol or butanol, that methane, ethane, propane, butane will come first when we are naming them. So this is ethyl butanoate, because it is coming from this part is ethyl alcohol hydroxyl. So this is ethyl. We will see much more example when we do the tutorial. It will be easier for us. Amide group. This is a little bit difficult to remember for students. I always find that students make many mistakes for this amide group. So I will ask you to take a special consideration or take some time for this to study the amide group. Okay, amide group. It is quite confusing. Sometimes it looks like amino group and also carboxylic group. Not carboxylic, is keto group, but it is actually CONH2. Okay, CONH2. Whenever it is together inside organic molecule, we know that this is the amide group. And amide is at the end of the name. We use it for nomenclature. All right, so I think this is much more of it, and then groups and their names is there. The ester and amine, this is what a heroine. Have you heard the heroine? What is the compound? Anybody has any idea? What is a heroine? Do you know what is heroine? No? No, it is not an actress. It is not an actress. It is the drug that destroyed a lot of people. And I've seen it in my eyes. So this is any drug, and all the drug is very bad. And all of them starts very small amount and then it destroys the life. So this heroin as well, it just needs a little bit. I mean, I don't know, it's even less than that in our nails we can keep. That it starts with that amount, and then within, I've seen people got totally destroyed, died. Within 2 years, they start taking the drug. And less than that actually sometimes. So this is a drug, and this is, all drugs are bad. This is one of the worst thing. And the ester amide group, we have to, amino group actually, we have to find out. So this is one, right? In fact, this is one, and this is another one. This is the ester group that we find, and amide group or amino group. This is one of the amino group we find. So when it is, if it's this type of problem is class or a question, you have to mark it. If you mark like for this case, if you mark something like this, or let me show you. Sometimes students just will mark like that. Show amide group or amino group, or sorry, carboxylic ester group, they will just mark like that. So that will be wrong. You have to mark all together, whichever, or if you mark in that way, if you mark in this way, that will be also wrong, because this thing you have included inside, which was not supposed to be included, right? So I mean, show precisely which group is what. So this is it. This is sorry, it should be, this carbon should be added inside. So these three are the groups. Okay, so this is the summary for us, and please go through it. The chapter, I mean the slides, and I'm sure that at the beginning you will have some problem, or maybe you will have some question a lot, and of course we will be discussing later on the questions during the tutorial. Okay, so bring your questions and we can join later on. Yeah, so that is it. Do you have any questions so far? Any other question? I mean, any question do you have? Anyone else? As usual, no questions, so it is quite okay for you guys to understand, hopefully. So I'll see you on Thursday for the lab, and it will be same face-to-face as well, and live through the same time, live through the MS Teams, just like the previous last week. So all the best, take care, I'll see you, bye-bye.
Thank you, sir.